Section 2.3, Venn diagrams and set operations. A Venn diagram is a useful technique for illustrating set relationships. These are named for John Venn. Venn invented and used them to illustrate ideas in his text on symbolic logic. The universal set is represented generally by a rectangle. The items inside the rectangle may be divided into subsets of U and are generally represented by circles. The circles labeled with the name of the set. For example, here we see set A inside of the rectangle, which represents the universal set. Two sets which have no elements in common are said to be disjoint, or another word we use is mutually exclusive. The intersection of disjoint sets is the empty set. Since there are no elements in common, there's no overlapping area between the two circles, and the Venn diagram would look like this. A proper subset, remember a proper subset, and when we have a Venn diagram where A is a proper subset of B, this is what it would look like. When two sets are equal, they have the same identical elements, and this is what this Venn diagram would look like. Set A and set B would be right on top of one another. Overlapping sets. This is when set A and set B are not mutually exclusive or not disjoint, and they have some elements in common. And this is the most general form of, in this case, a two-set Venn diagram. So again, disjoint sets are sets A and B are disjoint. They have no elements in common. And this is the general form that we use for a two-set Venn diagram when we label the regions 1, 2, 3, and 4. When they're disjoint sets, there won't be any elements in region 2 of the Venn diagram. When we have subsets, if we go back to the general diagram here, and if we have A as a subset of B, then region 1 will be empty because all the elements in A are also included in B. If B is a subset of A, then region 3 would be empty. If two sets are equal, then all the elements in the two sets would be represented in region 2, and regions 1 and 3 would be empty. When two sets have elements in common, generally we will see that be the most common that we'll see in the Venn diagram. We'll have some elements in region 1 that belong only to A but not to B. Elements that belong only to B will be in region 3, and elements that belong to both sets will be in region 2. And then finally, region 4 are elements in the universal set that do not belong to set A or set B. The complement of a set, symbolized with A with a prime, is a set of all the elements in the universal set that are not in set A. And here's what that looks like on a Venn diagram. Given that the universal set contains the letters A, B, C, D, E, F, G, and set A contains the letters A, C, and E, determine A prime and illustrate the relationship among the sets in a Venn diagram. Okay, so A prime is going to contain all the elements in the universal set that are not included in A, and those elements are B, D, F, and G. And here's what the resulting Venn diagram would look like. Set A contains the elements A, C, and E, and then A prime, or A complement, contains the remaining elements B, D, F, and G. The intersection of two sets, symbolized by A with an upside-down U, is a set containing all the elements that are common to set A and B, and this is region 2 on the standard Venn diagram. Let's work some problems with intersections. So given the universal set contains the elements 1 to 10, and then here's set A, B, and C, we want to determine some intersections. So let's take a look at the first one. We want the intersection of set A and set B. And I've listed the two sets here. So the intersection, again, are elements that are common to both sets. So we see 1 is in both sets, 3 and 8. So the intersection of A and B, sets A and B, is 1, 3, and 8. And then we want to take the intersection of set A and set C. Now set C has no elements, so when we take the intersection there's nothing in common with both of those sets, so the intersection is actually the empty set. Now we want to take the intersection of A complement and B. First we need to determine A complement. So A complement is going to be everything in the universal set not in set A, and that's going to be 4, 5, 6, 7, 9, and 10, and then we want to take the intersection of that with set B. So what's common to these two sets is going to be 6 and 7. And then finally, we want to take the complement of the intersection of A and B. So first we need to determine the intersection of A and B, which is 1, 3, and 8. And then we want to take the complement of that, which is everything in the universal set that's not included in this set. And that's going to be the set of elements 2, 4, 5, 6, 7, 9, and 10. So let's take another example with words. U is a set of all universities in a country. A is a set of universities with a football team. B is a set of universities with a business school. And we're going to assume an A and B, these are the universities in the country. And we want to describe B prime in this situation. So the complement of set B. So the complement of set B is going to be the set of universities in a country without a business school. Describe A complement intersect with B complement. So A complement will be the set of universities without a football team, and we want an intersection. So this is going to be the universities in a country without a football team and with a business school. Intersection, we use the word and. Union. The union of two sets is symbolized with A with a U, special symbol there, the set containing all the elements that are members of set A or B or both sets. And this represents regions 1, 2, and 3 on our Venn diagram. So let's work an example. So we've given the universal set and then 3 sets. And let's first do A union B. Now union is kind of the opposite of intersection. We want to get all the members of set A or B or both. So we're going to put all the elements together. So we've got 1, 2, 3, 4, 6, 7, 9. And then we want to take the union of A and C. If you remember in the last example, when we took the intersection of A with a null set, we got the null set. Now when we take the union, we're actually going to get the set A back again. And then we want to take A prime union with B. So first we need to figure the complement of A, which is shown here, and then take the union of that with B. And that's going to be the set containing everything except the elements 2 and 4. And then finally, A union B and take the complement. So first we need to figure out what is A union B, 1, 2, 3, 4, 6, 7, 9, and then take the complement, and that contains the elements 5, 8, and 10. Let's go back to the university one again, and let's work here with some union. So describe A union B here. So A union B would be the set of universities in a country with a football team or a business school. Use the Venn diagram to list the elements in the set U. So U is all the elements that we see in the Venn diagram. And if we look here, 1, 6, 9, 11, 15, 16, 20, 20, and 25, 24, and 25. Use the Venn diagram to list the elements in B complement. So if we notice, this circle here represents B. Everything outside of that circle is B complement. So B complement is going to be 1, 6, 24, and 25. And then use the Venn diagram to list the elements in A intersect B complement. A intersect B is right here, 9 and 11. The complement of that is going to be all the elements outside of that intersection, and that's the rest of the elements, 1, 6, 15, 16, 20, and 24. You see, when you have the elements in the Venn diagram, it's much easier to answer some of the questions. So again, let's go back to that and or. And intersection generally is interpreted to mean and. Intersection and. So A intersect B is the set of X such that X is an element of A and an element of B. And the word or is generally interpreted to mean union. X is an element of A or an element of B. The relationship between cardinal numbers for sets. Define the number of elements in the union of two sets. We add the elements in set A and set B and then subtract the number of elements that are common. And there's the formula. And the reason we subtract this, if you remember on the general Venn diagram, in the intersection region, those elements are counted in both set A and set B. If the sets were disjoint, this part would become 0. So let's work an example. The results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both. How many speak Spanish or French? So A is going to be visitors who speak Spanish. B is going to be visitors who speak French. We want to determine the number in A union B. So 25 speak Spanish, 14 speak French, and 4 spoke both. We simplify, so 35 people, 35 visitors speak Spanish or French.